Measuring flow is everywhere in a process plant. Water, chemicals, steam, gas, fuel. If it moves through a pipe, someone wants to know how much. But here's the catch. There is no single flow meter. There are many, and each one uses a completely different physical trick to measure the same thing. Pick the wrong type for your fluid, and your reading is quietly wrong from day one. So in this video, I will walk through how flow meters actually work, the main types, the one-line principle behind each, and how to pick the right one. Let us start. Quick note before we dig in. This is from PLC Simulator, where you can practice scaling a real flow signal free right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to the meters. Start with the oldest trick in the book, differential pressure, usually with an orifice plate. You put a restriction in the pipe, a plate with a hole in it. As fluid squeezes through, the pressure drops across that restriction, and flow is proportional to the square root of that pressure drop. Measure the drop, do the maths, you have flow. It is cheap, it is proven, and it is everywhere. The downsides? The orifice causes a permanent pressure loss in your line, and that square root relationship makes it weak at low flow rates. Next, the magnetic flow meter, the mag meter. This one has no moving parts and nothing blocking the pipe. A coil wraps the pipe and creates a magnetic field across it. When a conductive liquid flows through that field, it generates a small voltage, and that voltage is proportional to the flow velocity. It is Faraday's law of induction applied to a pipe. Mag meters are accurate, low maintenance, and great for dirty or corrosive liquids. The one catch: the fluid has to conduct electricity. So no oil, no gas, no pure water. Now the gold standard, the Coriolis meter. The fluid flows through one or two tubes that are vibrating. As mass moves through those vibrating tubes, it twists them very slightly. The meter measures that tiny twist, and from it, it reads true mass flow directly, not volume mass. It even gives you the fluid's density at the same time. It does not care about pressure, temperature, or what the fluid is. That makes it the meter of choice for custody transfer and billing. The only real downside is the price. It is the most expensive option on this list. 3 more worth knowing. Vortex. A blunt bar sits in the flow and sheds little whirlpools downstream. The faster the flow, the faster they shed, and that frequency gives you the velocity. Good for steam and gas. Ultrasonic. It fires sound pulses across the pipe and times them both ways. Flow speeds the pulses up downstream and slows them upstream. The clamp-on version straps to the outside of the pipe with no cutting at all. And turbine. A little bladed rotor spins in the flow, and its speed tracks the flow rate. Simple and accurate on clean fluids, but the moving parts wear over time. So which do you actually choose? Quick rules. Conductive liquid, like water or slurry. Reach for a mag meter. Need true mass flow or custody transfer for billing. Coriolis. Retrofitting a running line with no shutdown. Clamp on ultrasonic, since it never touches the fluid. Steam or gas. Vortex handles it well. And for clean, general-purpose, low-budget service, the old DP orifice or a turbine still earns its place. Match the meter to the fluid and the job, not the other way around. One last piece, how the meter talks to your PLC. Almost every flow meter sends one of two things. Either a 4 to 20 milliamperes analog signal, where the current rises with flow, or a pulse train, where each pulse is a fixed volume. Your PLC reads that raw signal and scales it into real engineering units. Liters per minute, cubic meters per hour. That scaling step is its own skill. I cover it in detail in my analog input video, link below, and you can practice it in the 4 to 20 milliamperes calculator in the description. So here is the whole picture. A flow meter is a category, not one device. DP and orifice use a pressure drop. Mag meters use a magnetic field on a conductive liquid. Coriolis reads true mass from a twisting tube. Vortex, ultrasonic, and turbine each have their niche. And whatever you pick, it lands on the PLC as a 4 to 20 milliamperes signal or a pulse to be scaled. Get that, and flow measurement stops being a black box. Now, go make it concrete. If you want to practice scaling a flow signal hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.